Hey guys, it's Mr. Arndt here, and today we're going to talk about mechanical advantage in levers. A lot of you are working on topic 1 in the science notes, and I got a lot of questions via email. So here's going to be a quick little explanation on mechanical advantage in levers. So whenever you're calculating mechanical advantage with a lever, you got two different ways to calculate the same thing. You can use the force or the weights on the lever, or you can use the distance of the different arms on your lever. So those are two different ways. The formula, if I'm using force, is going to be the force on the load side, what I'm lifting, and it's going to be divided by the force on the effort arm, which is where I'm pushing in on the lever. So that's the effort piece. In the example we have set up here on the table, we have a mechanical advantage of 1, MA1, and that's because the fulcrum of the lever is dead center in the middle, and you can see that it balances with the exact same amount of weight on each side. It's 200 grams on this side and 200 grams on this side. So whatever's going in is equal to whatever's going out, and that's the mechanical advantage of 1. I'm not lifting more weight or adding more speed or doing anything like that. It's just a 1-to-1 ratio. So let's take a look at the math calculations for doing mechanical advantage 1, and you'll see it's pretty easy calculation. So here I have my formula. Mechanical advantage is the force of the load side divided by the force on the effort side. So let's take a look at our diagram over here, and we have the load side is 100 grams. That's what we're lifting. That's over here. So I'm going to go 100 grams is my force of the load side. And you can see on this side I have 100 grams as well. That's the effort side. So that would be like me pushing down with my finger with 100 grams worth of force, or 100 newtons worth of force. So I have 100 divided by 100, 100 grams divided by 100 grams. 100 divided by 100 is 1, and actually when we're doing mechanical advantage calculations, the units cancel out too. Grams divided by grams cancel out, and so I actually don't have units on mechanical advantage. I basically am just having a 1-to-1 ratio, or one unit of weight goes in, 1 unit of weight comes out the other side, and there's no extra mass or force, which we'll see happens in some of these other examples. Let's do a quick calculation for the distance. Here we have the formula is mechanical advantage equals the distance on the effort arm divided by the distance of the load arm, and they're both 50 in this side. So I'm going to go 50 centimeters divided by 50 centimeters. Again, the 50 divided by 50 goes to 1. Centimeters divided by centimeters cancel out, and I have a mechanical advantage of 1 again. So we're going to talk about mechanical advantage 2, which is our second example. Here's the picture, and then I kind of have a little demo sitting right here. Basically, when we look at this, we can still do the calculations with force, and we can do the calculations with distance. Nothing really changes, but there are some neat things to look at when we move the fulcrum to one side. So we'll take a look at what happens when we do that. To start us off, before we get to the math, I'll explain some of those neat things. One thing, mechanical advantage of 2 is I actually have double the amount of distance, 2 times the distance here and 1 unit of distance here. On this meter stick, it's 100 centimeters long. I have 66 centimeters here, and I have 33 centimeters here, and 33 plus 33 is 66. So this one is 2 times as long as this side. And that is going to give us a mechanical advantage of 2. And we'll see when we get to the math that it does equal 2. It also gives us another little bit of an interesting piece, is that if I look at this side of my balance beam has 100 grams on it. This side has 200 grams. So again, the ratio, the mechanical advantage, the ratio is 2. Well, 100 times 2 is 200. So I put in, on my effort side, I push down with 100 newtons of force. I can lift something up 200 newtons of force. So now it takes me less effort in, and I get more effort out on the other side. So that's kind of nice. It makes this side lighter, and that's where a lot of people use levers as an advantage for you. So anytime you have an advantage of 2, or as long as it's not 1, you're going to see some trade-offs, right? So if I put in 100 newtons of force here, and I'm lifting 200 newtons of force, the trade-off is I can't lift it quite as high. So what I want you to do, I'm going to kind of like move the lever a little bit. It might fall when I do this demo, but when you notice, I'm going to move this side down, and I'm going to have to move this side twice as much as I move as this side ends up moving, the resulting side. So let's take a look here, and I'm gonna move this side, maybe I'll move it up about 5 centimeters, and you see that side's only gonna move down about 2 centimeters. So it's like, it's a little bit different. This side is moving way more to lift that side a little bit less. So that's the trade-off. It's easier to move, but I don't get as much height when I lift on that side. That's the trade-off. Let's take a look at the math really quick, and we will see that the mechanical advantage does equal 2. So let's take a look at the force calculation first. Here I have my force of the load side. The load side is 200 grams on this lever. That's what I'm lifting. So here I've got 200 grams. And on the effort side is 100 grams. So I'm doing 200 grams divided by 100 grams. And again, 200 divided by 100 is 2. The grams cancel, so my mechanical advantage is 2. All right, let's take a look at the calculation. We're using distance, which I can do. The distance formula is a little bit different. I put the effort side on top, so I've got 66 centimeters, and it's actually 66.6, but that's on my effort side. And then the distance of my load side is going to be 33. And if you do the math, you'll see, again, mechanical advantage is 2, so we have whatever we put in, we get double out. Okay, so for our final example, we're going to look at a mechanical advantage of 3. And again, this mechanical advantage of 3 means that I'm going to be able to lift 3 times as much weight on the load side of my lever compared to the effort side of my lever. So 3 times the weight. In the diagram, we've got it set up as far as 100 grams on here and 300 grams here. Unfortunately, we didn't have enough weights to do 100 and 300, so we did 200 and 600 because it's the same ratio. It's still times 3. 200 times 3 is 600. So we're going to talk about that a little bit. Again, you'll see in the demo that I do in just a second that when I move this arm here is going, I'm going to need to move this a lot, and I'm only going to get a little bit of lift on this side. I'm actually going to have to move this side 3 times as much to lift this side 1 time. So that's kind of the ratio. That's that mechanical advantage of 3. Although it's going to be way easier to move this side than it is to move the other side. So if you take a look, I'm going to move it up and down. I get very little movement on that side, and I'm moving quite a bit on this side here. So hopefully I didn't move it too much. Good. Okay, so there, that shows me how much I have to put 3 times as much movement on this side, 1 unit of lift on this side. So I get that ratio of 3 again. Let's take a look at the math really quick with the force, and I will use the numbers in the diagram here just to make it make sense to the diagram that's on the board. So mechanical advantage of 3, I have my force load and my force effort, or weights if I want to think about it. So we're going to do that first. The load side on this example here is 300 grams. I'm going to go 300 grams is my load side, and I'm going to divide that by the effort side, which is 100 grams, and that equals 3, so I have a mechanical advantage of 3. All right, let's take a look at the distance of the arms mathematically. Here we have the effort distance on top again, so we have mechanical advantage here is 75 centimeters on the effort arm, and we're dividing that by the distance of the load arm. Here's 25 centimeters. And again, we get a mechanical advantage of 3. There's mechanical advantage in a nutshell. It's different for class 2 and class 3 levers. We'll talk more about that next day.